Imagine you're driving down a deserted highway at night. Everything feels calm. Suddenly, the headlights don't just flicker, they vanish. Not because the bulbs burned out, not because the power grid went down. The light itself is gone, like something reached out and swallowed it whole. You slam the brakes, then the gas, but nothing changes. You're trapped in a darkness so deep it feels alive. And here's the scary part. There actually is something in the universe that can do this. It's not a monster, not a black curtain. It's real. We call it the black hole. But that's just the opening. The real story goes much deeper. A black hole isn't a hole in the ground, and it's not some sci-fi portal. It's a region in space where gravity is so insanely strong that nothing, not even light, can escape. It has a boundary called the event horizon. Cross it, and you're gone for good. From the outside, all we can see is the shadow, that pitch-black circle surrounded by glowing, distorted light. But inside, that's the mystery. So how on earth did we figure out something like this exists? To answer that, we need to rewind a century, to Einstein. In 1915, Albert Einstein rewrote the rules of the universe. Instead of saying gravity is just a force pulling two objects together, he claimed something radical. Space and time themselves form a fabric, what we now call space-time. Heavy objects like stars or planets sink into this fabric, warping it. And smaller objects like Earth follow those curves. Picture a trampoline stretched tight. Drop a bowling ball in the middle and watch the smaller marbles roll toward it. That's how gravity works. It sounded insane, complicated. Even Einstein admitted only a handful of people could really understand it. But 4 years later, during a solar eclipse, astronomer Arthur Eddington put it to the test. He photographed stars appearing to shift because their light bent around the sun. That bending was exactly what Einstein predicted. The theory wasn't just math anymore, it was real. And once space-time could bend, the door was wide open for things far stranger than anyone imagined. Newton's laws had explained the universe beautifully for over 2 centuries. Planets, apples, rockets, everything behaved exactly as his equations predicted, except for Mercury. The closest planet to the sun was misbehaving. Its orbit wasn't matching Newton's formulas. Astronomers scratched their heads, invented hidden planets, tried every fix they could imagine. Nothing worked. Then came Einstein's equations. They showed that the sun's massive gravity actually twists space-time more than Newton ever considered. That extra twist explained Mercury's weird orbit perfectly. It was the first big victory for general relativity, proof that Einstein was onto something. And if his equations could solve a centuries-old mystery, what else could they reveal? Here's the problem. How do you take a picture of something that swallows light? The solution was pure genius. Instead of building one impossibly huge telescope, scientists linked radio dishes across the entire planet. Together, they formed a virtual telescope the size of Earth itself. This network, called the Event Horizon Telescope, finally gave us what once seemed impossible. In 2019, the world saw the very first image of a black hole, the one at the center of galaxy M87, a glowing orange ring with a dark shadow in the middle. It looked like an eye staring back at us from across 55 million light-years. A few years later, they released another picture, this time of our own galaxy's central black hole, Sagittarius A. It was fuzzier, trickier, but still jaw-dropping. And yet, not everyone agreed on what they were really seeing. When the Sagittarius A image came out, some researchers argued that the picture might not be fully accurate. They suggested the processing methods, the way scientists piece the data together, could have created artifacts that weren't truly there. The EHT team defended their results, pointing out they used multiple methods and cross-checks. But the debate itself shows something important. Science is never about final answers. It's a constant conversation, pushing and questioning. Meanwhile, a completely different line of evidence was rolling in, literally, gravitational waves. Using giant detectors like LIGO and Virgo, scientists caught ripples in space-time from black holes smashing together. Each signal was a cosmic fingerprint, undeniable proof that these monsters are out there, colliding, merging, shaping the universe. So we can't dismiss them as theory anymore. They're real, and they're violent. Which brings us to the most terrifying question of all. Scenario 1. You fall into a small black hole. The gravitational pull on your feet would be millions of times stronger than on your head. Your body would stretch like spaghetti. Scientists literally call it spaghettification. Translation: you'd be torn apart in an instant. Scenario 2. You fall into a supermassive black hole, like the one in our galaxy. Here, the tidal forces at the horizon are much gentler. You might actually cross the event horizon without feeling anything, at first. But from the outside, anyone watching would see you freeze on the edge, never crossing, fading slower and slower. From your perspective, though, time ticks on. And once you're inside, no signals escape. Physics itself breaks down at the singularity, a point of infinite density. Is that the end? Or could another universe exist on the other side? Right now, that's the greatest unsolved mystery in science. Black holes aren't just cosmic curiosities. They teach us 3 mind-blowing lessons. First, the universe has boundaries. Cross them, and there's no return. Second, a theory written in 1915 still explains mysteries no one else could solve, and it's still ahead of us today. Third, discovery never stops. From blurry images to gravitational waves, black holes are both proof of Einstein's brilliance and reminders that we're only scratching the surface. So here's my question for you. If space-time itself can bend, twist, and collapse into a black hole, what else about reality could we be completely wrong about? Drop your thoughts in the comments, and don't forget to subscribe, because the next story from the universe, it might just be stranger than fiction.